The era of treating localization as an afterthought, as a simple copy-paste exercise at the very end of a product cycle, is completely dead. We are witnessing a fundamental structural collapse of the legacy systems we've relied on for decades, and the artificial intelligence replacing them is as ruthless as it is brilliant. If you're building global products and managing complex language operations, you already know the ground is shifting beneath us. You're tuned into Locanuku, the strategic localization update that cuts through the noise to bring you the intelligence you need to survive. Let's get straight into the engine room of what is actually happening in our industry. To understand the AI shift in language services, we have to look at the underlying mechanics. For years, we survived on baseline models, but the jump to deep learning neural networks changed the game, primarily through the encoder-decoder architecture. In this setup, the encoder compresses the source text into a comprehensive mathematical representation, and the decoder generates the target output. But here's the trick. These models don't read words like you or I do. They rely on embeddings and vectors. They map words into a complex mathematical space, understanding the semantic relationships based on how closely those numbers cluster together. Every time a word is processed, a new embedding is generated, fully informed by the context around it. The real breakthrough here was the attention mechanism. How does a model know which words matter most in a sentence? Attention dynamically calculates exactly which words in the input string relate to each other. Think about complex audio processing, like an international gaming lobby where players are rapidly code switching, blending 2 or 3 languages in a single sentence. Advanced models like Meta's seamless M4T rely on attention to decipher the true meaning of that mixed string on the fly, keeping accuracy high even when the language shifts mid-breath. But the total disruption came with the transformer. Interestingly, this wasn't originally built for general chatbots. It came out of a highly influential 2017 Google research paper called "Attention is All You Need," and it was engineered specifically for machine translation. Unlike older models that read text linearly, step by step, transformers compute dynamic attention scores for every single word against every other word instantly, regardless of where it sits in the sentence. This nonlinear approach brings us 2 massive advantages: incredible computational speed, allowing the model to digest massive datasets rapidly, and high accuracy, drastically reducing those painful grammatical and structural errors by capturing long-range dependencies perfectly. Now, before we declare victory, we need to talk about the persistent hangover of neural machine translation, or NMT. Transitioning to NMT didn't magically fix our workflows. In fact, it exposed severe architectural flaws, specifically regarding context. Taking content out of its natural environment and feeding it to an engine as isolated snippets creates massive ambiguity. Legacy translation management systems, your traditional TMS, have historically relied on a single sentence paradigm, ripping sentences away from their vital surrounding context. When you do that, mistranslations are guaranteed. Take software localization, for example. Without visual context, you get overlapping text, incorrect pluralization, and broken locale-specific formats for currencies and dates. Imagine you have a UI string that simply says log. Send that to a legacy TMS, and your machine translation engine is likely to translate it as a heavy piece of chopped wood rather than a system record. But modern platforms like Crowdin are fixing this by allowing context-aware machine translation. By uploading visual screenshots, the AI assistant actually sees the user interface and understands that log is a button to view account activity, delivering a perfectly accurate translation. Then there's the classic engineering reality of garbage in, garbage out. A model is only as good as its training data. If the input fed into the neural network is flawed, your output will be equally broken. And because generative models are designed to complete patterns, they will literally hallucinate answers when they lack information. This is incredibly dangerous. Imagine deploying an unconstrained, automated publishing script to push localized content without human oversight. Just like an unmonitored system could accidentally overwrite a live production website with raw, unformatted code, an unconstrained AI agent can cause catastrophic failures. You simply cannot hold an AI model legally accountable for a liability disaster. We cannot blindly trust NMT output without sophisticated workflows. This brings us to the harsh reality of implementing large language models. It is much harder than it looks on paper. You cannot rely on off-the-shelf tools. You have to build these use cases yourself. And that starts with prompt engineering, which is absolutely not just an overrated buzzword. When you talk to an LLM, every comma matters. Models need explicit instructions, rich context, and clear examples. If you prompt an image generator for a mouse on a mat, hoping for a picture of a computer accessory on a mouse pad, the model might literally give you a photo of a live rodent sitting on a yoga mat. It did exactly what you asked, but you lacked boundaries. It's like asking a teenager to clean the kitchen. If you don't explicitly tell them to wash the dishes and sweep the floor, they'll just wipe the counter and call it a day. Extreme specificity is mandatory. To pull this off, your technical skills have to level up. Python is highly recommended for modern localization engineers. There is a massive open source ecosystem out there with Python SDKs, but you have to know how to use them. If you can write code, call APIs, parse XML, and manipulate complex data structures, you unlock the future. If you can't, you are stuck relying on prepackaged, limited interfaces. We also have to talk about data security. When processing proprietary translations via an API, the rule is simple. Free does not exist. Free tools are training on your data. Paid SaaS models and enterprise APIs, however, offer strict guarantees that your data is purged and not used for internal model training. Always consult the privacy policies before feeding business-critical content to an LLM. And financially, you have to prepare for token pricing volatility. You pay for input and output tokens. If you dump thousands of pages of translation memories into a prompt to provide context, your token burn will skyrocket, making it a very expensive workflow. You have to weigh that API overhead against concrete return on investment, which is still hard to prove in many localization use cases. The TMS market is struggling right now. The legacy systems are saturated, operating on 30-year-old principles. They bolted LLMs onto their existing obsolete architectures to try and automate post-editing, but it's not enough. The single-sentence paradigm is dead. Furthermore, the translation memory itself, specifically the fuzzy match, is losing value. A fuzzy match is just a translation with a guaranteed error rate. If you get an 85% fuzzy match, 15% is broken. As LLMs generate highly fluent translations from scratch, forcing a linguist to fix a broken fuzzy match is a waste of time. We have a massive solutions void right now. Cheap web portals on one side, hyper-expensive enterprise platforms on the other, and very few customizable, open platforms in the middle that let you build retrieval-augmented generation or RAG integrations using your own vector spaces. If we map this against the technology hype cycle, we are currently descending into the trough of disillusionment. During the peak of inflated expectations, people asked LLMs to do things they weren't built for. It's like asking a generative model to draw a highly detailed medical diagram. The resulting image might look okay at a glance, but the text pointing to the organs will be illegible, alien-looking gibberish. People get mad and call the tool useless, but that's a user error. You shouldn't use a diffusion model for typography, just like you shouldn't blindly use an LLM for your entire translation stack without oversight. Acknowledging these limitations is how we build genuine, value-adding integrations. This is where AI agents and agentic workflows come in. We are moving from think-fast programmatic setups to think-slow autonomous systems. An AI agent has three core components: reasoning, where it digests the intent and plans a strategy; acting, where it autonomously uses tools like a web search, an API, or a DeepL translation engine; and memory access, allowing it to reference past interactions for context. When you combine reasoning and acting, you get a react agent, operating on a loop of think, act, observe, and repeat. Imagine building an agent to handle vendor invoicing. It wakes up when a PDF invoice arrives, reads the details, accesses your database tool to check the vendor's rate card against the purchase order, verifies the math, and autonomously emails the vendor a payment confirmation. It's powerful, but full autonomy is unpredictable and burns tokens. For translation, we don't need full autonomy. We need structured agentic workflows with medium to high predictability. Instead of a single pass, we chain agents together. Text goes to a primary translation agent. The output routes immediately to a terminology agent, whose only job is to check the text against corporate glossaries. From there, it could hit a transcreation agent to refine the style. Finally, it hits the quality agent. Instead of legacy algorithms, we instruct the quality agent on our exact criteria for success based on the style guide. If it issues a pass, the text publishes automatically. If it issues a fail, it routes to a human post editor. This fundamentally redefines how we look at quality. Quality is no longer about getting every comma perfect. It's about fit for purpose. It's like transportation. Taking a quick rideshare to the airport is perfectly fit for purpose for a business trip, but you wouldn't use it for your wedding day. You'd rent a luxury limousine. The outcome is transportation, but the quality expectation is different. For a corporate website, the 30% of pages driving massive traffic and conversions require that luxury, human piece of art translation. The other 70% of deep archive, low traffic pages, automated machine translation is completely fine. By measuring content performance, we can allocate budgets smartly and finally compensate human linguists properly for the high-value, creative transcreation work they do on critical content. We have to move past rigid legacy frameworks like MQM and DQF and stop relying on outdated blue scores that tell us nothing about real-world performance. This evolution requires us to transform from standard language service providers into global experience centers. We have to focus on outcomes, not rigid processes. If a project doesn't fit our tools, we change the tools, and those tools must support multimodality because the future is way beyond text. AI dubbing and video localization are the new standard, usually relying on a cascaded workflow. It starts with automated transcription, followed by metadata enrichment to tag speaker age and gender. Then comes the translation. Next, voice cloning selects and generates a highly accurate voice profile from just a few minutes of source audio. Finally, neural speech synthesis, which has totally replaced basic robotic text-to-speech by adding deep emotion and natural cadence, generates the audio, which is mixed back into the video. We are also seeing massive leaps in direct speech-to-speech translation, which will revolutionize low-latency interpretation. Meta's seamless M4T model is a powerhouse here, handling 101 languages for text and 36 for speech, processing complex multi-speaker audio with near-instant latency. Meanwhile, OpenAI's Whisper dominates transcription, Sora is pushing text to video, and integrating vision APIs with speech engines allows for real-time visual narration. Imagine an AI watching a live factory floor inspection through a webcam, instantly analyzing the visual data and generating a spoken, translated safety report in real time. That is the multimodal reality we are building. You can find more deep, actionable insights like this to future-proof your career at locanuku.com.